Now let's take a look at example 1C. Same again setup as the previous two parts. We have women, the population mean of 205.5 centimeters for the overhead reach distances, standard deviation of 8.6 centimeters, and the original population is normally distributed. Now, this time, we're going to look at a sample of 40 adult females and find the probability that they have a mean, that the mean of that sample of 40, their overhead reach is between 204 and 206 centimeters. So now, again, n is equal to 40 this time. And we're going to look at the shape, center, and spread of the sampling distribution with respect to a sample of 40 females. So, I'm going to extend the page here. So shape, again, it should be normal. But this time it's normal for two reasons. It's normal because the original population was normally distributed, but even if it wouldn't have said that, our sample size of 40 being larger than 30 would mean that the sampling distribution, the shape of all the sample means of size 40 from the population of adult females would be normal also. So we actually can do this for two reasons. Number one, again, the original population was normal, but secondly, our sample size was larger than 30. So this is normal for those two reasons, and I'm not going to write that down. The center, again, would stay the same as the population. The mean of the sample means from samples of size 40 would be, again, 205.5 centimeters. And then the spread will change because now we got a larger sample size. We're taking samples that are larger than in part B. The standard error would be, again, the population standard deviation divided by the square root of the sample size. Well, the population standard deviation, if I remember right, was 8.6. Yep, it was 8.6 centimeters. We're going to divide it this time by the square root of 40. So that gives us a standard error of about, again, I'm going to go about to 4 or 5 decimal places, 1.3598 centimeters. Now, 98 centimeters. Now, this value right here is smaller than the previous standard error because our sample size is larger. It was 2.86 here. Now, because the sample size is larger, it is 1.3598. And again, these are the two values right here that you're going to put into your StatApp. So what we want to do, ladies and gentlemen, is we want to find the probability that the mean overhead reach for a sample of 40 women would be between 204 and 206 centimeters. So I'm going to write this down this time before I go to the computer. We want to find the probability that the mean height of 40 women falls between 204 and 206 centimeters. So what does that equal? All right. Here we go. Here's our normal distribution. Again, the mean was 205.5 centimeters. The standard deviation this time was 1.3598. We're looking at between two values, and those two values are 204 and 206. And so again, this shaded in region is between those two values. So here's the percentage, 50.85%. So a little over half of samples of size 40 women will have a mean between 204 and 206 centimeters. But again, we need to change that over to a probability. So if we do that, we get, again, just change our percentage to a probability would be 0.5085. There you go.